Hello everyone, I'm Ajay. Welcome to Online Learning's Infosys DSE and SP training. Today we're going to solve a previous year DSE SP question. Come to the problem description. Given a number m and its decimal division, your task is to find the minimum base b such that its representation of m at base b all digits are same. Okay. Let's take an example. Okay. Suppose we took the example of 10. This is a decimal representation. We know there are various representation of numbers and we usually follow decimal, and in computer and all such statistical operations we use binary number representation, which is either 0 or 1, and we also have octal, which is of base 8. We have hexadecimal, which is of base 16. So in such way, let's see how the decimal to binary conversion is. So if you take the decimal number here, and if you want to convert to the base 2, then we need to divide 10 by 2 and we need to store the remainder. So remainder is 0 and the quotient will be 5. Quotient is not less than the base, so again we need to divide. The remainder is 1 here, quotient is 2, again divide 0. So and at last we need to reverse the reminders, that is 1 0 1 0. This will be the binary representation, that is base 2 for the number 10. So this way, there are various type of conversion, like decimal can be represented in various number of bases. The question asked is here, we need to find such representation in which the base should be minimum, the minimum base, and also the bits, the digits are all same, which means if suppose a number is like 3, 3 means 1 and 1 in base 2. So which means that here you can see the both the digits and digits are same. So this way we need to find such base. Here the base is 2, that's the minimum base. So we need to find such bases which will give the same digits in the complete representation of a certain base for a number. This way we need to find that. The basic approach is that everyone I think is that to start with base 2, because there is no base 1. Base 1 is just a 1. So start with base 2 and find every representation of that number and check whether all digits are same or not. If all digits are same, then we conclude this as the minimum base. This is the basic approach, but this would increase the time complexity more. So we'll optimize this approach further, and let's try to code this. I will be coding this in both Java and Python. First, I will code this in Java. Okay, open my IntelliJ editor. Sorry, IntelliJ. Yeah, IntelliJ editor. I created a file main.java, and so we need to have input. So I'm using a scanner. Scanner is equal to scanner, new scanner, system.in. So and we take the number as the input, se.next int, and I need to initialize the base. So starting base will be 2. Let's create a function, static boolean, because whether all that is the same or not, satisfy true or false, for indicating that I'm using the boolean type, and it will be compute or it can be same digits or not. Okay, same digit or not, so it will accept one is number and another is base. Yes, so let's calculate the remainder at the initial stage, that is base, sorry, number percentile base. Here my approach which I'm going to do now is, instead of calculating the complete representation of a base of a number to a certain base, we can do one thing. We can the first step will be to calculate the remainder, that is suppose 0 for the 10 here, so that will be some around k, and next step we will be dividing the number by the base and again calculating the remainder, and we will checking whether this remainder is equal to this or not, because first reminder is 0 here. So next reminder is 1 here for this 10. First is 0 and this is 1. So by this we can conclude that base 2 doesn't satisfy our condition, that is all the digits are not same. So even in one digit varies, then we can directly discard that base and we can just stop that loop and return back. And in the return back, what we have to do, the second step is previously base will be initialized to 2. We need to increment the base to 1, base plus plus. So this way what happens is that it will calculate the base, so base representation of a number, and will check one by one, and at any point the remainder or the previous iteration the remainder is not same, then it will immediately break and return back to the main function. And the main function, again we are incrementing the base plus plus. This way it will start from 2, it will check whether it's equal or not, negative 3, 4 and so on. So whatever the base will get, that will be the minimum base, because we are starting from the minimum number 2. So this is my basic approach. So I'm trying to code that. So initially I took the reminder, and as I'm took the reminder, I'm dividing the number by base using a while loop. While number greater than or equal to base, because until the number greater than or equal to base, we need to divide and find the reminders of that. And also we need to check whether number percentile base equal to remainder or not, because at any point whether it's not equal to the first remainder, then it means all digits are not same, so we need to break the loop, that is while loop. And here I'm dividing number equal to number by base. Then at last we will be having the final number and the remainder. So I'm checking whether that number is equal to the initial reminder. If it's equal, then we just need to return true, because all the digits are same. Else we just need to return false. So we have a function which checks whether the all digits are same or not. So let's create a while loop again here, and it will compute same digits or not. The first parameter is number, second parameter is base, and this will need to run until we find the minimum base. So for that I'm using not symbol. The not symbol will like if this returns false, that is this function returns false, it indicates that the representation doesn't contain all digits as same. So and I'm using not, so the false become true. So so that while loop will run until this function returns true. So whenever this function returns true, then this, because of this not, it becomes false. So while loop breaks, and whatever condition the while loop breaks, will print the base here. And we know that for every iteration we need to increment the base plus 1. So at any point when this function returns true, this while loop breaks. So in the whenever while loop breaks, we just need to print the base here, that is the base that which has the same number of representation. So our code is done. So let's run this. Yeah, so it's prompting for an input. Let's see a sample input here. Okay, 41 and 40. So if you give 41, 40, yeah. So one more input, 34430, 34430, 312. Yes, perfectly correct. So I'll do the same thing in Python. I'll just recap whatever logic I have done again. So I'm opening the Python. I'm using PyCharm for coding this. Same way, let's take the input for the number equal to int of input. So input is done and initializing base with 2. Let's create a function def same digits or not, same digits or not. In this I'm using number and base. Same way, calculating the reminder, the initial reminder, number percentile base, then again number equal to number divided by 10, sorry, base. So using a while loop again, we are checking here number is greater than or equal to base, because until then we need to iterate, and number greater than or equal to base, and reminder, sorry, number percentile base equal to reminder or not, and this is equal. Then also we need to divide the number by base. At last, we'll check whether the number is equal to reminder or not, the previously calculated. If it is, we'll return true. Otherwise, we'll return false. So in the main function, we are checking while not of same digits or not number comma base. If it is, then I'm incrementing the base equal to base plus 1, and finally printing the base. So let's run this. 41. Oh, sorry. Okay, 1 second. There are no semicolons. Yeah. So here also we have same number input base as 2, not of base. Okay. If number equal to return true, yes. Number percentile base, number equal number. Okay, and here also it's integer division. In Python we are using integer division. In Python, as the data type is in, by default it will take integer division, but for Python you need to explicitly mention the integer division here. Yeah, I guess rest all is same. Let's run this again. 41. Yeah, it's correct. So let's run the second input. 34430. 34430. Yes, so it's correct. So I'll just recap whatever logic we have done here. Initially, we took the reminder, that will be the first reminder, and each time we are dividing the number by the base so that we can get the reminder again, and we are checking whether this new reminder which we got is equal to the first reminder or not. If it's not equal, we can immediately say that the one of the digit is not equal to the previous digit, so this base is itself wrong. We can immediately break the loop and we can just return false. And if the loop doesn't break, so it will iterate till last, and we'll checking whether the number, that's the last one, is equal to reminder or not. Then we're returning true. This is when all the numbers are same, sorry, all the digits are same, which means all the digits will equal to the reminder. So all the digits are equal to reminder, so we are returning true. So whenever returning true, we are breaking the while loop in the main function. In the main function, we are breaking the while loop and printing whatever base we got till now. So that's it for this video. All the best. Thank you.